In this video, you guys are going to understand about digital electronics. Nowadays we say the word digital electronics for pretty much everything. Everything is digital, digital, digital. Everything is digital. Now, what exactly is the meaning of that word digital? See, you need to understand that there are two types. Okay, one is analog, one more is digital. When we talk about analog circuits or analog device, you can say whatever it is. Now, what we mean by analog circuits is that we have a continuous wave. Okay, in the sense, look at this particular graph. We have voltage, you have time, correct? In this, if you look at it, the voltage varies continuously with respect to time, isn't it? Now, when we say digital, see, in very layman terms, if you have to understand, it's all about ones and zeros. You either have it or you don't. There are no gray areas in between. Okay, this is what we mean by digital. But then the actual meaning of digital is far more intricate and advanced compared to this particular meaning. But to keep it very, very simple, you either have 1 or you have a 0. Okay, now look at this particular graph. If you need to have the peak voltage, we call it as 1 or you have a 0. That's all. This is basically bits, what we call as bit, like 1 or 0, 1 or 0. If it's a 1, it's yes. If it's a 0, it's a no. That's all. Very, very simple. Okay, now what we have is we are going to use the semiconductors, whatever you have studied so far, like diodes and transistors and everything. And we combine, like we make a combination of these devices and make certain types of circuits. Okay, and these circuits are what we call as gates. Okay, now this particular word gate actually has a meaning to it. See, the main reason for a gate is what? It divides or it separates, correct? Either this or that. There is no in between. So when we say logic gates basically they tell us, like, if this is the input, this is the output. In the sense, you either get a 1 as an output or you get a 0 as an output. There is no in between. Okay, either you stay on this side of the circuit or this side of the circuit. There is no in between. So those combination of these semiconductors acts like a gate. That means they either allow the current to pass through or they stop. That's all there is. That's why they are called as gates. And since we are talking about the mathematical part of it, we call them as logic gates. There are three types. Mainly there are three types of gates what you have. First one is an AND gate. This is the representation of an AND gate. You have two inputs, you have one output. Two inputs A and B, one output is Y. Okay. Now, whenever we talk about these gates, there is something called as a truth table. So, truth table is what input you give and what output you get. Just like, how we were drawing the graph, X and Y axis graph, same way, you have the truth table. So, in the truth table, see, you have A, B and Y. Now, what we do, we give the inputs. In the sense, suppose if A and B are 0 and 0, Y is also equal to 0. In the sense, suppose say you have switch. Okay, if both the switches are off, then obviously the output is also going to be off. Correct? This is how we are going to look at it. Now, second one, look at the truth table. 0 and 1, you have 0. 1 and 0 is 0. 1 and 1 is 1. Okay, now to understand this in a more logical way, think of a series circuit where you have two switch in series and you have a bulb. You connect it to a battery. If the bulb has to glow, see, if both the switches are off, the bulb is going to be off. Any one of the switches, if you turn it on, and if the other one is off, the bulb is still switched off. This is the meaning of 0 and 1 to be 0, 1 and 0 to be 0. Okay, if the bulb has to be on, then both the switches needs to be closed. That's the meaning of the last one. 1 and 1, the output is going to be 1. Are you clear? So, an AND circuit is basically like a series of what? Two switches. Clear? Mathematically, we denote AND in this way. Y is equal to A dot B, or A and B. We don't call it as dot, we call it as Y is equal to A and B. Clear? The second type of gate what you have is an OR gate. This is the circuit. Okay, likewise, an OR also has a truth table. So, in OR truth table, look at this one, 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, 1 or 1 is 1. See, I told you for AND combination, we have two switches in series. Now, what might be the circuit for OR gate? Just think about it. It's a parallel circuit. Two switches in parallel and they are connected to a bulb. See, if the bulb should not glow, then both the switches needs to be in off position, correct? You connect any one of them, like if you switch on any one of them, the bulb will glow. That's why 0 or 0 is 0, 0 or 1 or 0. Both of them will give you 1 as the answer. 1 or 1, obviously it's going to give you 1. Okay? Now, mathematically, this is how we represent. Y is equal to A or B. Third type of gate you have is NOT. Okay, now NOT is the reciprocal. NOT is the reciprocal. This is the symbol. Okay, you see that small circle in the front? That basically represents the NOT. Okay. Now, in NOT gate, the truth table is very simple. See, if you have 0 as the input, you will get 1. If 1 is the input, you will get 0 as the output. It's just a reciprocal. Okay. So, look at the truth table, 0, 1, 1, 0. And the symbol what we use is this one. We call it as Y is equal to A complement or A bar. This is a NOT gate. These are the three main gates. Now you have combination. You are going to combine AND NOT, which you will get it as NAND. Look at the truth table. Okay. You have OR, NOT. Combined together, you are going to have NOR gate. Look at the truth table for the NOR gate. Okay, now these are the main 5 logic gates what you have, and you are going to have just writing the truth table based on these things. Okay, so this is what we have in digital electronics. Very, very simple. You understand what is a bit like 0 and 1. Basically, 1 is a high voltage, 0 is like no voltage, like 0 voltage. Based on this, you have the gates, logic gates, where if this is the input, what's going to be the output. Correct? And 5 gates. AND, OR, NOT, NAND and NOR. And please remember the truth table for all these logic gates. Clear? So this is the last part of the chapter.